Hey everyone, so in today's video we're going to go over how to evaluate infinite limits. So for the first example, let's say that we have the limit as x approaches 2 from the right of 1 over x minus 2. So for this here, for the first step, we need to understand that x minus 2 is going to be a small positive number since it's approaching it from the right. So the smallest possible number we can have would be 2.000000001. So essentially we have 1 over a small positive number, and 1 divided by something that's super tiny is going to be super large. So our answer is going to be positive infinity. And on a graph, this would look something like this. And it would just shoot up. And where it starts, so here I started it right over here, we don't know that, or we can find that out, but the idea is that it would shoot up. Let's try another example. Let's say that we have, now let's just do the opposite of that. Let's do the limit as x approaches 2, but this time from the left, of once again 1 over x minus 2. So now, since it's approaching from the left, the x minus 2 is going to be equal to a small negative number. So now we essentially have 1 over a small negative. And that is going to be equal to 1 divided by a super small number, which is negative, is going to be negative infinity. So if we draw the same graph, but we put the asymptote at the same spot. Now it's approaching it from the left, but it's going to cut down. It'll be more gradual, but it'll cut down like that. It's going to be negative infinity limit. Let's try another example. Let's say now that we have the limit as x approaches 1 from the right side. And actually, no, let's say negative 1 from the right side, and of the value of 1 over x plus 1 squared. So for this here, the square makes the denominator always positive. And so as x goes to negative 1 from the right side, the denominator is going to be a very small positive number. So essentially now we have, once again, 1 over a small positive, which is going to be equal to positive infinity, since it's going to be a really big number and it's in fact positive. And for example 4, we'll change it up just a little bit. Let's say that we have the limit as x approaches 0 from the left for 2 over x cubed. So here, the x cubed keeps the sign of x positive. Or sorry, it keeps the original sign of x. So as x approaches 0 from the left, x cubed is going to be a small negative number, since the smallest number we can have is negative 0.000001. It's still a negative number though. So essentially we have 2 over a small negative, which is going to give us negative infinity. So the limit for this is negative infinity. A few key tips to remember: always check one-sided limits when dealing with infinity. Even powers in the denominator keep the value always positive, and same infinity for both sides. And then odd powers keep the sign of x the original value. I hope this video helped. Thank you.